We ended our last video partway through Model 2 of our sequential multiple regression example. Let's pick up where we left off with the coefficients table. Okay, here we are with the regression coefficients for Model 2. Our regression equation for Model 2 is the predicted grades equals 0.073 plus 0.119 times mother's education plus 0.043 times school quality. Looking at the unstandardized coefficient for school quality, we see that controlling for mother's education, a 1 unit increase in school quality is associated with a 0.044 unit increase in grades. And that is statistically significant with a t with 397 degrees of freedom equal to 2.516 and the p-value equal to 0.012. Remember, that 397 for the degrees of freedom comes from the residual degrees of freedom in the Model 2 ANOVA table. Now, looking at the unstandardized coefficient for mother's education, we see that controlling for school quality, a 1 unit increase in mother's education is associated with a 0.119 unit increase in grades. This is also statistically significant with a t with 397 degrees of freedom equal to 6.684 and a p-value less than 0.001. Now, notice how the effect for mother's education has changed between Model 1 and Model 2. Remember our path diagram for Model 1. In Model 1, we saw the total effect for mother's education on grades was 0.357. Now, if you think of the total effect as the sum of the direct and indirect effects, we saw that there couldn't be any indirect effects in Model 1 because there were no other variables in the model. It was all direct effect. So in Model 1, the direct effect and the total effect were equal. In Model 2, we've now added school quality. This is what Model 2 looks like in a path diagram. Again, the values for the blue paths from mother's education and school quality to grades are just the standardized betas for those variables in Model 2. Our standardized beta for mother's education is equal to 0.324, and that's the direct effect for mother's education controlling for school quality. It's the effect of mother's education that's unrelated to school quality. It tells us that controlling for school quality, a 1 standard deviation increase in mother's education is associated with a 0.324 standard deviation increase in grades. And our standardized beta for school quality is equal to 0.122. And that's the direct effect of school quality controlling for mother's education. It's the effect of school quality that's unrelated to mother's education. It tells us that controlling for mother's education, a 1 standard deviation increase in school quality is associated with a 0.122 standard deviation increase in grades. These direct effects, right, are the unique effect of each variable that's unrelated to the other. The effect of each controlling for the other variable. Now, that 0.122 for school quality is also the total effect for school quality, right? It's the effect for school quality after we've controlled for the effect of preceding variables in the model, like mother's education, but before we've added any later variables. And because there are no variables that sequentially come after school quality yet, school quality has no indirect effects. It has a path pointing to our outcome grades, and that's it. There's no causal path or effect, no arrow from school quality to some third variable and then from that third variable to grades. In a way, it's similar to the situation when we had Mother's Education all on its own in Model 1, and Mother's Education had no indirect effects. But let's look at Mother's Education now. Notice how the effect for Mother's Education has changed from Model 1. In Model 1, the total effect for Mother's Education was 0.357 with no indirect effects. But by adding school quality, we've split that total effect into direct and indirect effects. As we said a moment ago, the direct effect for Mother's Education on grades is that 0.324 that's unrelated to school quality. That's the effect that controls for school quality. The difference between the total effect and the direct effect is the indirect effect through school quality. The impact that mom's education has on grades by more educated moms having children attend better quality schools, leading to better grades. So do you see what we've done? It's still that same total effect of 0.357. We've just carved it into one part that's unrelated to school quality, the direct effect, and another part that's the effect through school quality, an indirect effect. Now, because it's the same total effect, you can infer that the size of the indirect effect is just the difference between the total effect of 0.357 and the direct effect of 0.324. But as we'll see later in path analysis, indirect effects can get kind of messy in complex models. So you actually want to calculate them, and we'll learn how to do that later. But before leaving the path diagrams, there are two additional points I want to make. First, notice that our model says that Mother's Education has an effect on school quality. It's this dashed line. But this analysis doesn't give us a value for that effect. That's also something that we'll learn how to do when we cover path analysis. And second, notice that the regression coefficients measure direct effects. Remember, a regression coefficient estimates the effect of a variable controlling for all the other variables in the model. It's the unique effect of a variable that's unrelated to all of the other variables in the model. That's also the definition of a direct effect. Regression coefficients are direct effects. In contrast, the indirect effects have to be calculated by combining coefficients. And again, we're not going to worry about how to do that yet. But I want to be clear of how regression coefficients are direct effects. And again, that's true whether you're using standardized coefficients and talking in terms of standard deviations, or whether you're using unstandardized coefficients and talking in terms of the original raw units. It's the same direct effect. And remember, it's the same effect when we talk about it as a unique variance based on the squared semi-partial correlations. The unstandardized regression coefficient B, the standardized beta, and the squared semi-partial all describe the same thing in different ways. It's all the unique effect of a variable controlling for or statistically removing the effect of all of the other variables. Whether it's the value of the coefficients in a regression equation, or the values of the paths in a path diagram, or the unique variances in a Venn diagram, they're all the same effect, just described in different ways. Now, before wrapping up, let's actually revisit the Venn diagram, focusing on the unique effects. To do that, let's first square our semi-partials so we know how large those unique variances are, okay? Expressed as a variance, the unique effect of mother's education is just the semi-partial of 0.311 squared, or 0.097. And the unique effect of school quality is just 0.117 squared, or 0.014. And we can see that in the Venn diagram, right? We can see this. But notice the change in mom's education. When we looked at the cumulative change in R squared, the effect of mother's education was 0.128, and mom got credit for the overlap with school quality, but not when we're looking at the unique variance. When we talk about the unique effect for mother's education in Model 2, we're focused on that 9.7% of the variance in grades that's only related to mother's education. That gray area, right, our old C, is out of the picture. And if you think about it a bit, you might see that one way of conceptualizing that grayed out shared variance is that it reflects any indirect effects involving these two predictors. Now, based on our model, our sequential model, we think that it reflects the indirect effect of mother's education on grades through school quality. But again, that's a reflection of our model. So you can see sequential multiple regression provides a lot of information, not just about the effect of a set of predictors on the outcome, but it also provides some hints about the relationships among the predictors themselves. In our next video, we'll continue with this example by looking at the results for Model 3. Okay? Take care.